Your diesel is belching black smoke every time you hit the accelerator. You take it to the mechanic, and they hit you with the classic line, "You need a new turbo." That will be $2,500 to $4,500, parts and labor, maybe more. And if you are driving a heavy-duty truck, you are looking at $6,000 to $10,000 for a VGT replacement at the dealer. But here's the thing. In about 80% of cases, your turbo is not actually dead. It is choking. Carbon deposits have built up inside the turbine housing, around the variable geometry vanes, across the EGR valve, inside the combustion chamber, and throughout the exhaust system. That carbon is strangling your engine's ability to breathe, and when a diesel cannot breathe properly, it dumps unburned fuel straight out the tailpipe as thick black smoke. Now, Japanese mechanics figured out something decades ago that Western shops are only now catching on to. Instead of ripping apart your engine or dropping thousands on a brand new turbocharger, they developed a method using hydrogen and oxygen gas generated from nothing more than distilled water and electricity to burn out every last bit of carbon from inside the engine in roughly 30 minutes. No dismantling, no chemicals, no $4,000 repair bill, just water, science, and a machine that costs the shop about $2 per session to run. Let me explain exactly how this works, why it is so effective, and why your local dealer would rather sell you a new turbo than tell you about it. First, let's understand why your diesel is making black smoke in the first place. Black smoke is unburned diesel fuel. That's it. When the fuel entering your combustion chamber does not burn completely, it exits through the exhaust as visible soot particles. This happens when the air-to-fuel ratio gets disrupted. Too much fuel and not enough air, and you get incomplete combustion. The causes are usually one or more of the following: clogged or dirty fuel injectors that are not atomizing fuel properly, a restricted air filter limiting airflow, a malfunctioning exhaust gas recirculation valve, recirculating too much exhaust gas, or, most commonly, a turbocharger that is not delivering enough boost pressure because the variable geometry vanes are seized up with carbon. Here is what most people do not realize. Modern diesel engines equipped with variable geometry turbochargers are specifically designed to adjust airflow at different revolutions per minute. Small movable vanes inside the turbine housing open and close to control how exhaust gases hit the turbine wheel. At low engine speeds, the vanes close down to speed up exhaust flow and spool the turbo faster. At high engine speeds, they open up to prevent overboosting. It is brilliant engineering, but there is a massive weakness. These vanes operate directly in the exhaust stream, constantly surrounded by soot, carbon particles, and extreme heat that can exceed 1,500 degrees Fahrenheit. Over time, carbon deposits build up in the grooves where the vanes sit and around the unison ring that controls their movement. The unison ring is a critical component. It is essentially a metal ring that rotates to open and close all the vanes simultaneously. When carbon, rust, and corrosion accumulate on its contact surfaces, the ring binds up. Once enough carbon accumulates, the vanes start sticking. When they stick in the open position, you lose low-end boost, and the engine feels sluggish with black smoke under acceleration. When they stick closed, you get excessive back pressure, sky-high exhaust gas temperatures, and potential turbo failure. One diesel forum user with a 6.7-liter Cummins described his truck as feeling completely dead below 2,000 revolutions per minute, with clouds of black smoke at every stoplight. The dealer quoted him $4,800 for a brand new whole-set variable geometry turbo and actuator. he decided to try cleaning it first. This is where the Japanese technique comes in. The process is called hydrogen carbon cleaning, also abbreviated HHO. A machine uses electrolysis to split distilled water into its base components, hydrogen gas and oxygen gas. This mixture, often called oxyhydrogen or Brown's gas, is then fed directly into the engine's air intake while the engine idles. The hydrogen enters the combustion chamber, mixes with the fuel and air, and burns at a significantly higher temperature than diesel alone. That intense heat does not damage the engine, but it does something remarkable to carbon deposits. It essentially superheats them, causing a controlled pyrolysis that breaks the molecular bonds holding the carbon together. The carbon converts back into hydrocarbon gas, combines with the oxygen to form carbon dioxide and water vapor, and exits cleanly through the exhaust. The entire process takes between 20 and 45 minutes, depending on engine size and how severe the buildup is. For a standard passenger diesel, 30 minutes is the sweet spot. For larger commercial engines, mechanics might run it for up to 60 minutes. During the procedure, you can literally watch the exhaust change from thick and dark to nearly clear. It's dramatic. Some shops film the process because clients can't believe the difference. Before and after emissions readings show reductions of up to 70% in carbon monoxide and hydrocarbon levels. Mechanics who offer this service measure diesel particulate filter back pressure values and report significant drops after a single session, confirming that the filter is cleaner and the engine is breathing easier. One European workshop documented an average power recovery of 8 to 15% across the diesel vehicles they treated, simply by restoring airflow and combustion efficiency that carbon had been robbing for years. Now, why do I call this a Japanese technique? Japan's automotive maintenance culture is arguably the most meticulous in the world. Their inspection system, called Shaken, requires vehicles to pass rigorous testing every 2 years, and failing means your car is essentially grounded. Japanese workshops pioneered hydrogen cleaning technology as a cost-effective way to keep engines compliant with strict emissions standards without expensive part replacements. The technology spread through Asia into Europe and is now gaining serious traction in the United States and worldwide. Companies manufacturing these machines range from operations in Japan and China to certified European manufacturers. The fundamental science hasn't changed since the early days. Electrolysis of water, hydrogen combustion, carbon removal. Simple, effective, proven. Let's talk numbers. A new variable geometry turbocharger for a Ford 6.0-liter or 6.7-liter Power Stroke runs $1,000 to $1,700 for the part alone. Labor adds another $500 to $800. For a Cummins HE300 VG or HE400 VG, you are looking at $1,000 to $200 to $3,000 for a remanufactured unit, and new OEM units can push past $4,500. Heavy-duty commercial truck turbos from dealers can hit $6,000 to $10,000 installed. Add in the downtime cost, which for commercial fleets has been estimated at over $700 per day in lost productivity, and a simple turbo issue becomes a multi-thousand-dollar nightmare. A hydrogen carbon cleaning session at a shop? Most places charge between $150 and $350. Some mobile services will come to your location for under $200. The machine itself uses about 2 to 3 liters of distilled water per session and roughly 5 kilowatt hours of electricity. The actual operating cost per vehicle is around $2 to $5. That's it. No replacement parts, no dismantling, no days waiting at the dealer. Hey, before we continue, if you are finding value in this and you had no idea this technology existed, hit that like button. It genuinely helps push this video to more diesel owners who need to see it. Now let me be straight with you. Hydrogen carbon cleaning is not a magic bullet that fixes everything. If your turbo bearings are shot, if the turbine wheel is physically cracked, if your actuator is electrically dead, no amount of carbon cleaning is going to save it. You need a new turbo. But here is the critical point most mechanics will not tell you. The vast majority of turbo-related symptoms, the black smoke, the power loss, the sluggish throttle response, the boost codes, are caused by carbon fouling, not mechanical failure. One owner on a Duramax forum cleaned his VGT vanes with a chemical soak and reported the truck felt completely different afterward, like it had its original power back. He said he had planned to replace the entire turbo, but figured cleaning it was the least he could try. The worst that could happen was it still ran the same. After spraying power foam into the back of the turbo, letting it soak for 30 minutes, then blasting it with compressed air and repeating the process, the difference was night and day. Multiple Cummins owners have documented similar results after hydrogen cleaning sessions with trucks that were throwing P2, 262 boost pressure codes going back to normal operation. Even dealerships have accidentally proved this works. One owner was quoted $1,460 for a replacement turbo, but the dealer was able to recondition it by cleaning, and the truck ran fine afterward. The dealer said it probably just needed some cleaning because the vanes tend to stick in these turbos. The reason more shops are not offering this comes down to economics. A turbo replacement generates $2,000 to $5,000 in revenue for a shop. A carbon cleaning session generates $150 to $350. Some dealerships have started offering the service, but most still push for the expensive repair first. Can you blame them? That is a 10-to-1 revenue difference. Meanwhile, the independent shops and mobile diesel services that do offer hydrogen cleaning are booking solid because word is spreading. So how do you know when to clean versus when to replace? If your diesel shows these symptoms, gradual loss of power over time, increasing black smoke under load, rough idle, rising fuel consumption, sluggish turbo response, or frequent diesel particulate filter regeneration cycles, carbon buildup is almost certainly a factor. Get a carbon clean first. It is the equivalent of checking the simple, cheap fix before committing to the expensive one. If a $200 cleaning session restores your truck's performance, you just saved yourself thousands. For prevention, there are a few things every diesel owner should do. First, drive the engine hard periodically. Diesels are heat engines. They are designed to work under load. Short city trips at low revolutions per minute are the fastest way to carbon up your turbo and intake. Studies have shown that diesel engines, driven primarily in stop-and-go traffic, develop carbon buildup at 2 to 3 times the rate of engines regularly driven under load on the highway. Get it on the highway, let the exhaust gas temperatures climb, and let the engine burn off deposits naturally. Some mechanics even recommend what they call an Italian tune-up, essentially just driving the vehicle hard for 20 to 30 minutes on the highway, keeping revolutions per minute up and the turbo working. It is free and surprisingly effective at keeping vanes from sticking. Second, if your truck has an exhaust brake, use it regularly. Activating the exhaust brake keeps the sliding nozzle ring on the VGT moving, which prevents it from seizing. This is especially important on trucks like the 6.7-liter Cummins equipped with the whole-set HE351VE, which is notorious for actuator issues when the vanes are not exercised often enough. Third, use quality diesel fuel and consider a detergent additive every few tanks. Low-quality fuel with high impurity content accelerates deposit formation. Fourth, keep up with air filter changes and EGR maintenance. A clogged air filter alone can shift the air-fuel ratio enough to increase soot production significantly. Finally, consider scheduling a hydrogen carbon cleaning every 30,000 to 50,000 miles as preventive maintenance, especially if your driving involves a lot of city work, idling, or light load conditions. Fleet operators who have adopted this schedule report fewer DPF issues, fewer turbo failures, and measurably better fuel economy across their vehicles. It is cheap insurance against the $3,000 to $5,000 turbo replacement nobody wants. The bottom line is this: black smoke from your diesel does not automatically mean you need a new turbo. In most cases, it means your engine is dirty and it needs to be cleaned. A 30-minute hydrogen carbon cleaning session using water-derived gas can restore boost pressure, eliminate black smoke, improve fuel economy, and extend the life of your turbocharger, DPF, and EGR system, all for a fraction of the cost of replacing any single one of those components. Japanese mechanics have been doing this for years. It is time the rest of the world caught up. That's all for today. If this video saved you from an unnecessary $3,000 in repairs, do me a favor and smash that like button. Subscribe and hit the bell so you catch the next one. Drop a comment if you have tried hydrogen carbon cleaning or if you are still stuck dealing with black smoke. I read everything. Thanks for watching, and I'll see you in the next video.